So when you apply statistics to the real world, one of the biggest downfalls is that when you have really large samples, you might have a statistical significant difference. So there might be this, statistically, there is a difference between these two groups. But sometimes that doesn't really connect to the practical world of saying practically there is a difference. So, for instance, you could have two samples where the difference in means might be 0.0001. That's super small, and we could say that statistically there is a difference, and that is because the sample sizes were so large that there is a difference. Doesn't matter how big of a difference there is, but there is a difference. So we would instead like to ask the question, what about practically? So if there is a statistical difference, how much is that a practical difference? Because if for instance, it costs millions of dollars to implement something to change that, and there's not that much of a practical significance, it doesn't matter that you have statistical significance. But if there is a very large practical difference in these and it's expensive, then you have justification of saying, no, we need to make a change to be able to have something be adjusted. So one of the ways to be able to figure out this practical significance is Cohen's d. To see what is this, the measure of effect size. Basically, what effect does this have? Is it a big or small type of effect? And it's going to be based on the difference of two means, and these are from independent samples. So we're not going to look at matched pair samples, and we're not going to be looking at proportions. This is only for means. So it's going to measure the strength of the difference and then determine if the effect is small, medium, or large. So there's this formula here. So this is a formula that you will have to be able to use. So I'll give this to you, but you have to know how to plug things in, and you're simply plugging in things like the sample sizes of the ends, or the sample standard deviations, or our sample means. And this will give a practical idea of how big the difference is. So we get a number, and we have this general guide for us of whatever number we get popped out here, what type of effect do we have? Is it very small to being a large difference? So for instance, if d is less than 2, it's going to be a very small. So if it's between -2 and 0.5, it's small. Between 0.5 and 0.8, it's medium. Larger than 0.8, the effect is large. So what that means is we're saying that a large effect says that practically there is a large difference between these. As opposed to being very small, there's not a very practical difference between these. So when it comes to kind of getting a general feel of what does this mean, if you have a large effect size, that means that that's perceivable from the naked eye. So if, for instance, if we were looking at the average width of a cap of a bottle, right? You could look at two bottle caps and perceive there to be a difference between those. If it's perceivable, then that would correspond to something like a large effect size. On the other hand, something like a small effect size, what that means is that if you do intensive study, and so maybe you are a trained specialist at looking at bottle cap sizes, if you do that enough, you could perceive these differences that the average person wouldn't be able to perceive. So with intense study, you would be able to tell that there's a difference, but it's not really going to be noticeable at all by the naked eye or by the average person. So that's just some general guidelines. This is something that it's not super set in stone. There's other ways of doing this, but this is one of the easiest and most widely used studies for practical significance.